Hello friends, let's start off with rationalization of surds of order 2 today. So when two surds are multiplied together such that their product is rational, the two surds are called rationalizing factors of each other's, which we also call them RF of each other. And the process of rationalizing a surd by multiplying it with its rationalizing factor is called rationalization. So let's say if we have, let's take an example. Let's say we have a surd which is 5 root 2, and if I multiply this by 3 root 2, right? So this is one third, this is another third. If I multiply both of them, I'll get 15 into 2, which is 30, which is a rational number. So 3 root 2 and 5 root 2 are said to be rationalizing factors of each other. However, the point to be noted here is that 5 root 2, I could have also multiplied 5 root 2 by 2 root 2, and I would have got the answer as 10 into 2, which is 20, which is also a rational number. So 5 root 2 and 2 root 2 are also rationalizing factors of each other. So that means the rationalizing factor may not be unique. Okay, it can be different. So depending upon the question, mostly they'll ask the question that find the least rationalizing factor. So depending upon that, depending upon the question, we can get the final answer. So let's take an example. So let's say the question is we have to find least rationalizing factor for the first sum. So let's say the question is root 27. Now, obviously, for root 27, someone can say I can just find root 27 into root 27 and I can get the answer as 27. So, root 27 is the rationalizing factor, but that is not the least rationalizing factor. So, that's not what they've asked. So, this will be incorrect answer. So, what I'll do is in such a question, I'll first try and simplify root 27. So, root 27 I can write as 9 into 3, which in turn gives me 3 root 3. Now, 3 root 3, the only part which is which is important to us is root 3. So what I'll do is 3 root 3, I'll multiply by root 3, and this will give me the answer as 3 into 3, which is 9, which is a rationalizing number. So in fact, if I have to answer this question, the least rationalizing factor, so I'm just writing LRF. So LRF for this one will be root 3. Okay, let's take one more question. Let's say we have the question as 2 root 125. So again, 2 root 125 I can simplify, so I can write this as 25 into 5. So basically what I'm doing is I'm just trying to get the perfect squares and taking the square root. So 25 square root is 5, so I'll get 10 root 5. Now I'll multiply 10 root 5 by root 5, so this will give me 50. So that means the least rationalizing factor for this particular question is root 5. Okay, now let's try some other questions wherein you have a denominator where we need to simplify by rationalizing it. So let's say the question is rationalize the denominator. This is the question. Rationalize the denominator, and the question is 1 by root 2. And let's take one more, 5 upon 2 root 2. So how we can go about this question? So 1 by root 2. So what I'll do is 1 by root 2, I'll multiply and divide by root 2. So this will give me root 2 upon 2. So I have rationalized the denominator and I got root 2 by 2. Correct. Now in the second question, I have 5 upon 2 root 2. So again, the only thing which is important here is root 2. So I'll just multiply and divide by root 2. So what I'm doing is actually I'm multiplying, dividing by the same number. So I'm not changing the question. Okay. Right. So now we know how we rationalize the denominator. Let's say if in the denominator we have something like this. Let's say we have, the question is again same, rationalize the denominator, and the question is in this way. We have a binomial in the denominator. So if you get a question like this, so what you'll do is you'll multiply by the conjugate of this. So multiply and divide by the conjugate. So what is actually a conjugate? You change the sign of this term, multiply by 3 plus root 7 and divide by the same term 3 plus root 7. So now what I get is 3 plus root 7, and this is a minus b into a plus b, which is a square minus b square. So what I get is 3 plus root 7 upon 9 minus 7. So finally the answer is 3 plus root 7 by 2. And if you want, you can separate this. You can write this as 3 by root 2. I'm sorry, 3 by 2 plus root 7 by 2. If we have a question like this, if x is equal to 2 plus root 3, then find x square plus 1 by x square. So let's say this is the question. So I can divide this question into two parts. So I know I need to find x square plus 1 by x square. But if I put the values of x directly here, so it might get a bit complicated because in the denominator I'll have the whole square of 2 plus root 3. So what I'll do is in this question I'll write, I'll try to I'll try to manipulate this by writing this way: x plus 1 by x, the whole square, is actually equal to x square plus 1 by x square plus 2. This is the expansion formula. So in fact what I can do is I can write this as x plus 1 by x, the whole square, minus 2 is equal to x square plus 1 by x square. So instead of finding this, I can find this part. So this will be a bit simpler. So let's see how we can do it. So for x, I'll write 2 plus root 3 plus 1 by x, which is 1 upon 2 plus root 3, the whole square, minus 2, right? Now 2 plus root 3 in the numerator is fine. There is no problem here. We don't need to rationalize this. But the denominator, we should rationalize. So 1 upon 2 plus root 3. So what I'll do is I'll multiply and divide by its conjugate, or I can say by the rationalizing factor. So this is 2 plus root 3. So I'll multiply by 2 minus root 3 upon 2 minus root 3, the whole square, minus 2. So what I get is 2 plus root 3. Here what I'll get is 2 minus root 3. And now a plus b, a minus b is a square minus b square, which is 4 minus 3, which is 1. So this is 1. So now I can cancel this part. And this is what? 4. And 4 square is what? 16. 16 minus 2, which is 14. So sum becomes extremely simple. So once we know rationalizing, we know how to manipulate this question. So it would be very easy to solve the denominators which has irrational numbers. So hope you enjoyed this session. We'll see you in the next class. Take care. Bye bye.